Hello everyone watching this video. I am Mehek and I welcome you to today's video lecture in which I am going to explain you everything that you need to know about DNS. So let's begin. First of all, we need to know what DNS is. DNS, which stands for Domain Name System, is a crucial protocol for connecting to websites on the internet. To explain you better, it's like a phone book for the internet. Instead of remembering IP addresses, which are a series of numbers, we can use domain names which are easier to remember. Now, there are three types of servers in DNS: root servers, generic servers, and authoritative servers. So, imagine you want to access a website on the internet. Let's say the website is www.example.com. But you don't know the IP address of the server where the website is hosted. This is where DNS comes in. I told you that it's like a phone book for the internet. So instead of remembering IP addresses, we are going to use domain names. Now, the three types of servers, how they are used, I'm going to explain you that. First of all, the computer has its own cache memory, and so does the DNS resolver. If the website IP address is not present in the cache memory of the computer or the DNS resolver, then the request is sent to the root server, which is the top level server in the DNS hierarchy. The generic server, also known as the recursive server or caching server, is responsible for caching DNS query results. So when your computer sends a query to .com TLD server asking for the IP address of example.com, the TLD server responds with the IP address of the authoritative server for example.com. The generic server then caches the response, so if another user requests the same information later, it doesn't have to go through the entire process again. The generic server returns the IP address of example.com to your computer, and your browser can now connect to the server hosting the website. Finally, the authoritative server is responsible for providing the correct IP address of a specific domain name. When the generic server sends a query to the authoritative server, it responds with the correct IP address. In summary, we can say that the three servers in DNS work together to ensure that you can access websites using domain names instead of IP addresses. The root server provides information about top level domains, the generic server caches and retrieves information, and the authoritative server provides the correct IP address for a specific domain name. Now let's come to the iterative versus recursive method used in DNS. There are two methods used in DNS, iterative and recursive. Iterative DNS resolution is a process in which a DNS server returns the best available response it has to a query. The client then sends another query based on that response until it receives the final answer. In recursive DNS resolution, the DNS server performs all the necessary queries on behalf of the client and returns the final answer. Recursive DNS resolution is used when the client requests a domain name that is not present in the local DNS cache. The iterative method is faster because the DNS server returns the best available response it has to a query, and the client then sends another query based on that response until it receives the final answer. This method is preferred when the DNS server cannot provide a complete answer to a query. On the other hand, the recursive method is slower because the DNS server performs all the necessary queries on behalf of the client and returns the final answer. However, this method is preferred when the client requests a domain name that is not present in the local DNS cache. Now let's address this question, why DNS? The main purpose of DNS is to make it easier for users like us to access websites on the internet. Without DNS, users would need to remember the IP addresses of every website that they want to visit. This is not only difficult but also impractical, especially with the vast number of websites on the internet. DNS makes it easier for us to access websites as they only need to remember the domain name, like we remember the name of Google, Facebook, Instagram, etc., which is translated into the IP addresses by the DNS server. DNS uses both UDP, which is User Datagram Protocol, and TCP, which is Transmission Control Protocol, depending on the circumstances. UDP is a lightweight protocol that is used for sending small amounts of data quickly and without any error checking. When you send a DNS query to a DNS server, it will typically respond with a short answer that fits within a single UDP packet. This is because UDP is fast and efficient, but it doesn't guarantee that the packet will be received by the recipient. TCP, on the other hand, is a more reliable protocol that is used for sending larger amounts of data that require error checking and retransmission if necessary. When a DNS response is too large to fit into a single UDP packet, it will be sent over TCP instead. In practice, DNS mostly uses UDP, but it can fall back to TCP when needed. For example, if a DNS response is too large to fit into a single UDP packet, the DNS server may respond with a message telling the client to switch to TCP to retrieve the full response. So we can say that DNS can use both UDP and TCP depending on the size of the response being sent. UDP is fast and efficient but doesn't guarantee delivery, while TCP is slower but more reliable and can handle larger amounts of data. Now, lastly, a DNS domain name system uses a specific port number to allow communication between clients and servers. This port number is 53 for both UDP and TCP. So, when a client needs to resolve a domain name to an IP address, it sends a DNS query to a DNS server on port 53. The DNS server then responds with the DNS response, which contains the IP address associated with the requested domain name. So, this was all that you needed to know about DNS. I would be happy to answer any questions that you have in the